number 15. A curve has equation y is equal to fx, where fx is equal to 7x e to the power x over the root of e to the power 3x minus 2, where x is greater than the natural log of the cube root of 2. Part A. Show that the derivative of f of x is equal to 7e to the power x, bracket e to the power 3x, bracket 2 minus x, bracket plus ax plus b over 2, bracket e to the power 3x minus 2, everything to the power 3 over 2. So for part A, we are going to use the quotient rule, which is v du by dx, take away u, d by dx, everything divided by v squared. So we'll first set our u as 7x e to the power x and our v as e to the power 3x minus 2 to the power half. For our du dx, we are going to have to use the product rule. So we are first going to multiply 7x by the derivative of e to the power x, which is just e to the power x. We're then going to add e to the power x multiplied by the derivative of 7x, which is just 7. So we could write this as 7 e to the power x. For our dv by dx, we are going to use the chain rule. So we are first going to bring the half down. We are going to multiply by the derivative of the bracket. So we've got 3e to the power 3x. And then for the bracket, we are just going to lower the power by 1, which gives us e to the power 3x minus 2 to the power minus a half. We can now just substitute everything into a quotient rule. So the derivative of f of x is equal to e to the power 3x minus 2 to the power half multiplied by du dx, which is 7x e to the power x plus 7e to the power x minus our u, which is 7x e x multiplied by a half 3e to the power 3x e to the power 3x minus 2 to the power minus a half over v squared, which will be e to the power 3x minus 2 to the power half squared. Now we can look at all the terms that we can simplify. So we've got our first two terms, which just remain the same for now. Here we can then multiply our 7 by a half and 3. So 7 times 3 is 21. So we can write this as 21 over 2 x. And then we've got e to the power x multiplied by e to the power 3x, which would give e to the power 4x. Bracket e to the power 3x minus 2 to the power minus a half. And if we square our denominator, our power would just disappear. So we can write that as e to the power 3x minus 2. Whenever we are doing a show that question, we always need to go back to look at what the question has asked us to show and then try to see what we can do to get there. So as we can see, our denominator is to the power 3 over 2 in the answer, but at the minute our power is only 1. So to make that power 3 over 2, we are going to multiply all the terms by e to the power 3x minus 2 to the power half. So e to the power 3x minus 2 will just have a power 1. We've still got the 7x e to the power x plus 7e power x minus 21 over 2 x e to the power 4x. And if we multiply our indices, minus a half plus a half would just be 0. So that second bracket would disappear. And then in our denominator, we can now have our e to the power 3x minus 2 to the power 3 over 2. If we still look at the denominator, we can see that it's been multiplied by 2. So we are going to multiply all the terms by 2. So for the first terms, what we're going to do is we're going to factorize our 7e to the power x outside and multiply it by 2, which gives us 14e to the power x. We've got bracket e to the power 3x minus 2. And then to factorize that second bracket, we would put x plus 1 minus, if we do 21 over 2 times 2, that just makes that 21x e to the power 4x over 2 bracket e to the power 3x minus 2 power 3 over 2. So now we're getting closer to what our question was asking us to show. We now can see that in our answer, it's just 7e to the power x that has been factorized outside. So we are going to make sure that we factorize just 7 outside. So if we can see, we've got 21 and 14. So if we just put 7e to the power x outside, we would open a bracket and put 2, e to the power 3x minus 2, x plus 1, minus 3x. And now our power of e can become 3x, and the denominator would remain the same. We then keep the 7e to the power x, and then expand those two brackets, which would give us xe to the power 3x plus e to the power 3x minus 2x minus 2. And because we have got this 2 outside both the brackets, we will multiply all the terms by 2. So that would make it 2xe to the power 3x minus 2e to the power 3x. The minus 2x becomes a minus 4x, and our minus 2 also becomes 4. And we've still got the minus 3xe to the power 3x, and our denominator will remain the same. We have then got these two like terms that we can simplify. So we keep the 7e to the power x as it is. We can then start by writing our 2e to the power 3x, and then minus xe to the power 3x, minus 4x minus 4 over our denominator. For our final step, we've still got 7e to the power x, but in our bracket, we just want to factorize the e to the power 3x. So we'll put e to the power 3x bracket, 2 minus x, minus 4x minus 4 over 2 e to the power 3x minus 2 to the power 3 over 2. And that is in the form that we needed it to be, so we have shown our answer as required. Part B says, hence show that the x-coordinates of the turning points of the curve are solutions of the equation x is equal to 2e to the power 3x minus 4 over e to the power 3x plus 4. So for part B, we know that at the turning points, our derivative of f of x is always going to be equal to 0. So in part A, we got our f of x as 7e to the power x, bracket e to the power 3x, bracket 2 minus x, minus 4x minus 4 over 2, bracket e to the power 3x, minus 2 to the power 3 over 2. And because we are looking at the solution for the turning point, we are going to equate this to 0. We know that e to the power x cannot be 0, which means that term there cannot be 0. And we also know that the denominator of any fraction cannot be 0. So that shows us that only e to the power 3x, 2 minus x, minus 4x, minus 4 is equal to 0. So we are first going to expand the bracket to get 2e to the power 3x minus xe to the power 3x minus 4x minus 4 is equal to 0. We are then going to move all the x terms onto one side, so we'll have 2e to the power 3x minus 4 is equal to xe to the power 3x plus 4x. So we've moved that and that term. We can then factorize our x outside, so we will have x bracket e to the power 3x plus 4. And if we divide both sides by e to the power 3x plus 4, we will get x is equal to 2e to the power 3x minus 4 over e to the power 3x plus 4. And we have now shown that as required. The next part says the equation x is equal to 2e to the power 3x minus 4 over e to the power 3x plus 4 has two positive roots alpha and beta, where beta is greater than alpha. The student uses the iteration formula x n plus 1 is equal to 2e to the power xn minus 4 over e to the power 3xn plus 4 in an attempt to find approximations for alpha and beta. Diagram 1 shows a plot of part of the curve with equation y is equal to 2e to the power 3x minus 4 over e to the power 3x plus 4 and part of the line with equation y is equal to x. Use diagram 1 on page 42, part C. Draw a staircase diagram to show that the iteration formula starting with x1 is equal to 1 can be used to find an approximation for beta. So because our x1 is 1, what we are going to do is we're going to use a vertical line going first to the graph. and then a horizontal line going to the line. From that point, we draw another vertical line going up to the graph, and then another horizontal line going to our line. We then do another vertical line, and then the next horizontal line, as we can see, gives us a value at beta. From this, we can also see that if we go down on the first point there, that's our value x2, and that point there would be our value of x3. So that is our answer for part C. The next part says, use the iteration formula with x1 equal to 1 to find to 3 decimal places, part D, I, the value of x2. So what we're going to do here is on our calculators, first store x1, which is 1, as our answer, and then put in the formula that we have, which is 2 e to the power 3. And for our x1, we're going to put answer, 3 answer, minus 4. And in the denominator, we are going to put e to the power 3, again multiplied by our answer, plus 4. And that gives us our x1 as 1.502 to 3 decimal places. For D part 2, we've been asked to find the value of beta. So to find the value of beta, we're first going to have to find the value of x3. So if we just press equal sign again, that gives us our x3, which is 1.873 to 3 decimal places. And if we again press equal, we will now get our value for beta, which is equal to 1.957. The next part says, using a suitable interval and a suitable function that should be stated, E, show that alpha is equal to 0.432 to 3 decimal places, which means that we need to equate this function here equal to 0. However, we saw also in part B that our denominator here cannot be 0, and also e of x cannot be 0. So the part that we are going to equate to 0 is going to be the same part we used in part B, which is this part of the equation here. So for part E, because we've been asked to state a suitable function, we can say let g of x be equal to the equation we've been using, which is e to the power 3x, bracket 2 minus x, minus 4x minus 4. And the suitable intervals that we can use are the lower bounds and the upper bounds of the 0.432. So we can substitute the lower bound and upper bound for x. So our lower bound will be 0.4315. So we're going to substitute that into our function. And our upper bound is going to be 0.4325. So if we substitute our lower bound into this equation, wherever x is, we will get a value of minus 0.002275. And if we substitute the upper bound, which is 0.4325, we will get a value of 0.007261. After this, what we can say is that as there is a change of sign and the curve is continuous between 0.4315 and 0.4325, that means alpha is equal to 0.32.